Hello everyone. In today's video, I'm going to discuss about RNG. RNG is a hardware module present inside STM32 devices. RNG stands for random number generator, and as the name suggests, it generates random numbers. So in our RNG introduction, we can see that it is a hardware module that generates 32-bit values or 32-bit random values. And also it has qualified certain tests, which basically tells us the random number then generated by this RNG module are reliable and not pseudo-random numbers. So this is the program that I've written. In my case, I'm using STM32F4 series board, STM32F405 to be specific. And in this program, I have created a 32-bit variable called random underscore value, inside which I'm going to store the values that are going to be generated by this random number generator. So here I've already written the program. I'm not going to waste your time by writing the program in the video. I'll just explain the program. So before writing this program, we need to understand one thing, that RNG has its own separate clock, and it is also written in the datasheet. So here in the reference manual, it is mentioned that RNG clock is separate from our H clock frequency, and they have done this so that the quality of random number is independent of the H clock frequency. So I can show you that with the help of this clock configuration that we can see in the STM32 project. So in our clock configuration table also, we can see there is one separate clock source that is coming from main PLL that gets fed to the RNG and few other devices as well. So it is separate from the rest of the clock pulses. So to make our program work or to make our RNG work, we have to configure our PLL. And before configuring PLL, we have to make sure that our PLL is off, because when it is in off condition, then only it can be configured. So that's what I'm doing here in the first line of program. I'm making sure that my PLL is off. You can do that by going to RCC CR register, that is clock control register. So here in the reference manual, we can see inside RCC clock control register, we have a bit called PLL on bit, which is present in the 24th position. And by writing 0 to this bit position, we can make sure that our PLL is off, and we can continue with the configuration of the PLL. So for configuring PLL, there is a register called PLL configure register. Again, you can come to this reference manual and we can see PLL configuration register. So there are few bits inside this register, and they are present in 24th, 25th, 26th, and 27th bit position, which are used for the division factor of the clock that is going to be fed to the RNG. So if you read description of these bits, and they are called PLL bits, it basically tells us that main PLL division factor for USB OTG, SDIO, and random number generator. So basically the clock that is fed to this random number generator and few other devices are first divided by this factor, whatever factor we put in here. Okay, so our clock will be divided by this factor, and then it will be fed to the random number generator. So to set the value of these PLL bits or division factor, what I'll do is first I'll go to the clock configuration of this STM32. So you can create an STM32 project, and there you'll find clock configuration table. Okay, so this will basically help us to do the math or the configuration for this PLL. So what I'll do is, in this PLL, first you have to make sure that your clock is not more than 48 megahertz, because it is mentioned that random number generator needs a frequency that is lower than or equal to 48 megahertz to work, which means this in this clock source, I can put maximum of 48 megahertz. So if I put something more than that, for example, if I put 59, then it will show me this warning that the frequency searched for is out of range. So I have to put either 48 or less than 48. So I'll go with 48 here. I'll press enter. And here you'll see this bit, this Q bits is set as 3, which means my division factor is 3. So here in this PLLQ, I will write 3 to achieve 48 megahertz of clock source for my RNG. So that's what I have done in the program. In this PLL configuration register, I've written 3 shifted by 24, which means I'm writing 3 in these bits, PLL bits or my division factor. Now, once that is done, I can turn on my PLL again to make it work. So I'm basically writing 1 in that same position, 24th position, PLL on bit. Then you have to turn on your RNG peripheral clock. So same as using any peripheral, you have to turn on your RNG peripheral. So my RNG peripheral is present inside this AHB2 ENR register. So the sixth position or the sixth bit is RNG enable bit. So to use this RNG, I have to turn on the peripheral clock for this RNG. After that, I have to enable the RNG bit that is inside the RNG configuration register. So I can go to RNG, and here you'll see inside this RNG control register, I have a bit that is RNG enabled. So I'll set it as 1. Once we have done that, now our RNG or random number generator is ready and it is generating random numbers, random 32-bit values. But we cannot directly read the value that is present inside RNG data register. So the data that is generated by random number generator gets stored in this register called RNG data register. So 32-bit values that are basically generated by random number generator are stored here. So we have to read the value from here, but we cannot directly read it. We have to make sure that the data is ready to be read. So for that, there is a bit called data ready bit that is present inside status register of RNG. So when the data is ready, it will basically turn this bit, data ready bit, to 1. Okay. So what we will do in our program is we'll wait inside a while loop until unless this bit is equal to 1. And once it is 1, we'll read the data. And here I have provided some software delay so that I'm not continuously reading the data from data register, and I'm reading it after some time, so that we have time to see the actual value that is generated in the DR in our debug window. So that's it. Now we can run this program to see the output. I'll put it in debug mode. In the live expression, I have already imported the variable that we had created, 32-bit variable, random value. Now, when I run this, you'll see we are getting random 32-bit values. And these values are getting generated by this RNG module. And we are reading it from RNG data register. So this is how you can generate random 32-bit values with the help of random number generator in STM32. This is all for today. Thank you for your time.